Okay, let's rotate. Switch off. Damn, so fast. What is the speed of this fan? Hi class, this is the first method that we use to measure the velocity and acceleration of the blade rotation speed and also the swirling speed of the fan. And this first one is we use Kinovia application. So these are the variables that we fix in the first method. The first one is we fix the angle to the 0 degree, and then we fix the radius of the fan to 18 centimeter, and for the last one we fix to the frame rate to 60 frames per second. This is the result that we got from the extracted video in the Kinovia application. So the first one is blade of rotation from the front view. We got the speed of 0.00579 and then the velocity of negative 0.0022, and then we got the acceleration of negative 0.00116. And then for the next one is the swirling fan that we recorded from the top view. We got the speed of 0.00576 and then the velocity of negative 0.0037, and we got the acceleration of negative 0.00721. So this table of Kinovia analysis will be analyzed and then compared to the theoretical calculation next after this.
Next, we consider the second method to know the velocity and acceleration of the rotation of the blade. Using the theoretical calculation from the fan, we have measured and we have get the value of OC, which is 0.11 meter, and CA is 0.8 meter. Then from the Kinovia, we have also get the value of speed blade rotation is 0.307 rpm, while the speed of swirling is 0.3057 rpm. After all the information that we get, let's dive into and calculate the velocity of rotation blade first. Firstly, we need to calculate two angular velocity, which for the blade and the swirling. Like shown in the slide, we will use the formula speed time 2 phi divided by 60, and omega naught will present the angular velocity of rotation blade, while the ohm symbol represent the angular velocity of the swirling fan. After that, we calculate the total angular velocity by adding these two omega naught plus the ohm. We have include the vector of IGK represent the XYZ plane. So the total angular velocity that we get is shown in below. Then we calculate the velocity by times the angular velocity with the radius. And after the calculation, we get the velocity of the rotation blade is negative 0.002258 meter per second.
Then, we continue to calculate the acceleration of the blade rotation. Before that, we need to calculate about the angular acceleration that need to time the ohm with the total angular velocity. As shown below, we get the value is 0.10272 radian per second. Then, we have to continue to calculate the acceleration by angular velocity times radius and plus the total of angular velocity time with the velocity rotation of blade. After that, we will get the answer as shown below.
We will next be moving on to the discussion of this project. Firstly, as can be seen in the previous slide, for the values of when using Kinovia, the negative value of the Kinovia might due to tracking a point on the fan blade moving from right to the left, which is based on the chosen positive direction. Secondly, the experimentally measured and theoretically calculated velocity and acceleration at the blade tip show remarkable agreement, suggesting that its accuracy in both Kinovia analysis and also theoretical modeling. Thirdly, the similarity in swirling speeds further validates the chosen theoretical approach and experimental setup. Fourthly, the slight difference in blade rotation speeds highlights potential limitations in either the Kinovia tracking or the theoretical assumptions that we use. And lastly, further